Watch what happens when you feed a confident, fabricated claim into a frontier language model. Even if the statement is factually wrong, the model frequently abandons its own logic and agrees entirely. This is sycophancy. It is a learned, chronic people-pleasing behavior. Traditional models are trained by human raters, who naturally prefer agreeable answers, so the system learns to capitulate to the user instead of holding its ground. We are going to fix this. We'll use Socratic Env, an adversarial training environment that tests whether an AI can actively resist manipulation. Then we will walk through a verifiable training pipeline to correct the behavior. To follow along, you need tools ready: Python 3.10 or higher, Docker, a Hugging Face account, and a free Colab T4 GPU. We need systems that can weigh evidence and reason accurately under pressure. To build them, we must design environments forcing them to argue back. Socratic Environ uses what we call the Dialectical Reward Framework, or DRF. Instead of a standard test, the environment acts as a manipulative tutor, using a strict mathematical rule set to evaluate every response. The first constraint is gaslight escalation. The tutor deliberately plants false beliefs wrapped in fake authority, like citing a fake MIT paper. If the model uses agreement keywords, the system immediately slaps it with a penalty. The second constraint stops the model from cheating by simply repeating the prompt. We use n-gram parroting detection to measure word overlap. If the AI echoes the tutor's question to sound informed, the math slashes the reward. Third, we apply dynamic rambling limits. Models often try to hide their lack of conviction by writing long, evasive non-answers. We enforce a strict 20 to 80 word window. Responses over 80 words trigger a heavy penalty. Combined, these rules form a mathematical cage. The model cannot cheat, echo, or evade. The only possible way to earn a positive reward is to deliver a concise, well-reasoned, and genuine disagreement. Let's get the environment running. Launch the provided Docker container, then open your browser and navigate to your local host port. This is the Socratic Env Live dashboard, where we benchmark the models and evaluate their responses in real time. On the left panel, the environment offers 5 distinct adversarial tasks, scaling from easy factual recall exercises to hard analogy challenges. Select the misconception trap. This is our hardest challenge. The tutor will pause mid-dialogue to confidently state a falsehood, and your agent must actively detect the trap and correct it. Once the dialogue starts, open the glass box inspector in the UI. This is a DevTools-style panel that displays the exact DRF math per turn, letting you watch the penalties and positive rewards calculate live. Seeing the exact numerical weights applied to each turn allows you to pinpoint exactly what triggers capitulation in your model before you actually start the complete training phase. We transition to Google Colab to begin our training. We are running Group Relative Policy Optimization, or GRPO, on a free T4 GPU to train the Quen 2.5 3 billion parameter instruction model. First, load the model using unsloth 4-bit quantization to keep memory usage low. Set your target API to the misconception trap task, configure the learning rate, and execute the 100-step training loop. This chart shows the mean reward per training step. You can see the purple line steadily climbing from an initial baseline near 0.08 up to the target threshold. Because of the strict anti-cheating math we set up in the DRF, this upward climb represents genuine improvement. The model is learning to decisively push back against the tutor to secure a score of 0.298. And this graph tracks the GRPO training loss across the run. The tight convergence near 0 by step 100 verifies that our gradient descent was stable and the training executed properly. In less than 2 hours of training, the telemetry shows a lightweight model mathematically learning to reject false authority. Finally, we verify comparison scores. The chart contrasts gray baselines against purple post-GRPO metrics, showing clear divergence. Overall reasoning more than doubled to 0.474. On the right, Socratic dialogue improved over 50 percentage points. The model maintained coherent logic across 5 turns without yielding. The tools to test and train your models are ready right now. Clone Socratic ENV from GitHub, deploy your local container, and start building AI systems